Okay, going into our 1.2 notes. The big thing today, all right, our learning target, it's to understand those basic terms, right? We need to know our definitions and what we call postulates. All right, so that's the big idea of today. We're going to learn a lot of basic ideas, these building blocks of geometry. So, what geometry is, it's a mathematical system based on facts. All right, so we know things are true, and since they are true, we were able to form this type of mathematics. So it's based on facts, basic terms, which we're going to talk about today, right? Because that's our learning target. So built on facts, basic terms, and definitions, right? These are the three building blocks of geometry, right? You need to know basic facts, you need to know basic terms, and you need to know definitions, all right? And we'll dig into that more as we progress throughout this year. So, in geometry, some words, all right, some words are undefined, right? There is no definition to them. You can't open up a dictionary and find this definition. We have three words like that. All right, these three words are point, line, and plane. All right, point, line, and plane. There is no definition for those three words. All right, here's the thing though. We use these three words. Right? We use the word point, we use the word line, we use the word plane to build definitions of other geometric shapes, really. Right? You know that a square, right? A square is four lines, right? And more specifically, four lines that are all the same length, right? And you could do the same thing with a triangle, right? Triangles, three lines, right? But there is no definition for lines. We use these to build other figures, right? And although we don't have a definition for these things, you know what they mean. If I told you to draw a line, you can do it. If I told you to draw a point, you can do that, right? These are just the building blocks, all right? So, let's jump down here, right? And actually just talk about these three things. Now, there is no definition, but we can describe it. All right, so this is how we describe a point. Okay, so what a point is, it indicates a location, right? Think about it as like a map, right? Your iPhone, your Google Maps, right? If you could drop a point on a location, right? You pinpoint it, right? So a point indicates a location. Here's the big thing, all right? It technically has no size. You cannot see it. I know it's weird, right? But you cannot see it. So a point indicates a location, has no size. All right, well, how do we name a point, right? Well, you can't just, right, or I should say, we are going to be doing a lot of writing, right? So how do you write this down? If I want to talk about this point, all right, so this is how you do it. You represent a point by a dot, all right, like an actual point, by a dot, and you name it with, here's the big thing, a capital letter. All right, so for example, all right, if I want to talk about point A, all right, it's very simple. You draw a point and then you label it with a capital letter. That indicates point A. If you want to talk about point C, okay, here's my point and I'm going to give it a capital C. Simple as that. All right, so a point. All right, the next one, a line. Okay, well, again, we know what a line is. A line is a straight path that extends in both directions, right? Opposite directions. And the thing about a line, it doesn't end, right? It extends in two opposite directions without end. It goes on forever. All right, and here's the weird thing, right? A line has no thickness, right? Again, I know when we draw it, we need to give it thickness so we can visually see it, right? Just like a point has no size, but we need to give it a size so we can visually see it. A line goes on forever and ever, and it has no thickness. All right, what a line is, right? A line contains infinitely many points, right? So the way you create a line, and this is why it has no thickness, is because you take an infinite amount of points and you just put them next to each other. That's how you get a line, right? And remember, since points don't have size, that means a line cannot have thickness. All right, so how we talk about a line. All right, there are two ways we name lines. So I'm going to give you both. We use this way the most often. You can name a line by 2 points on the line. That is the most often way we do it. All right, there is a second way, and sometimes it is given a lowercase letter, and I'll show you an example of that. All right, so let me give you a picture. Okay, so again, remember a line doesn't have thickness, but in order to visually see it, right, it has to. Right, so and a line is made up of an infinite amount of points. We'll put a point A, point B, point C, point D, point E. Right, there's more than that, right? All right, sometimes there is a small lowercase letter that is given next to a line, not always. All right, so this is how we would name it, right? You would just take any 2 points. Take any 2 points on that line. What are 2 points? All right, well, B is on this line. What else is in there? D. All right, BD's on that line. Another way, AE. Another way, CB, right? There's a whole bunch of ways to name this. All right, now 2 things I want to point out. All right, since we're talking about a line, you need to draw a line over these points. That tells me we're talking about line CB, line BD, line AE. Okay? And normally with geometry, the first letter is our starting point and the second letter is our ending point. All right? Now, since this is a line, doesn't matter where I start and where I end. And it shouldn't, right? Because it is extending in both ways. So I am saying I'm going to start at C and extend towards B. All right, so I'm going this way. But remember, by definition of a line, it also extends that way. All right, this will matter when we start building other terms like rays and segments and things like that. When we start building other terms, this will come into play. All right, another thing that will come into play, all right, is BC. Is line BC the same thing as line CB? Let's look at it. Well, remember, this is saying I'm starting at B and extending towards C. Well, isn't that the same thing as what I have? Because remember, a line extends both ways infinitely, so it doesn't matter. All right, the other way we can name this line then, right, like I said, it's normally you use 2 letters, any 2 letters on the line. Order does not matter one bit. Sometimes it is given a small capital letter, so we can call this line M. Sorry, small lowercase letter, not capital letter. All right. So completely up to you. You just have to see what is given. All right. There's millions, hundreds of right answers. Actually, infinite, right? Because there's infinite points. All right. The last one is a plane. All right. So what a plane is, it is a flat surface. All right. So we went from just a dot to a whole bunch of dots to create a line to now creating a surface. So a plane is a surface that extends again without end, just like a line. It extends without end and has no thickness, right? And this is why, right? Because a plane is an infinite amount of lines, right? To create a plane, you just lay a whole bunch of lines next to each other, and that's how you get a surface. All right, think about a wall, right, or ceiling or the ground, right? Those are surfaces, right? Those are infinite amounts of lines. All right, planes. There are two ways to do this as well. So sometimes, just like a line, a plane gives you a capital letter that you can use. So you can name a plane with a capital letter. All right, more often than not, you won't have that. You'll have to do it this second way. All right, the second way is by using at least 3 points. 3 points, and here is the key word, that are not on the same line. So let me give you an example of that. All right, so again, a plane, right, it's just a surface. All right, so let's just draw a surface. All right, and sometimes, right, the surface, remember, a plane has an infinite amount of lines on there, right, and lines are made up of an infinite amount of points, right? So there are just lines and points all over this thing. All right, so I can start naming these points: A, B, C, D. Just because of time, I'm not going to name all these. F. All right. So that's what a plane is. All right, it contains an infinite amount of lines, which in theory then contains an infinite amount of points. All right, all labeled. All right. Now sometimes they give you a capital letter in the corner. All right, so these are the 2 ways you can name this plane. All right, you can call this, you would write the word plane, we don't have a symbol, plane P, because that is the capital letter in the corner. All right, otherwise, you have to use 3 letters, 3 points that are not on the same line. I don't care if 2 of them are, all 3 of them cannot. So I can use, I have a whole bunch of points here. I can use D, I can use E. Those 2 are on the same line, I understand that, but as long as my third is not, it doesn't matter. So pick a point that's not on this line, D, E, B. That works, right? Again, so many ways to name this, D, E, B. All right, you could do A, B, C. Are those on the same line? A, B, C, no. As long as all 3 of them, again, I don't care if 2 are, the thing is 3 cannot be. All right, 3 cannot be. A, F, D is another way. All right, B, D, E is another way. There's a whole bunch of ways to name this plane. Okay, so continuing on with more terms. We have 2 definitions here, collinear and coplanar. All right, they're pretty simple to remember. All right, so we'll start with collinear. Collinear means points that lie on the same line. That is what collinear means, points that lie on the same line. All right, it's pretty easy because the word line is in there, linear, right? Co, right, meaning together, right? So together on the same line, collinear. All right, and remember, lines, right? The only reason this says points, right, is because lines are made up of points, right? You can't have anything else on a line besides a point. All right, so when we talk about coplanar, right, the same idea, plane meaning plane, right? Planar meaning plane, co meaning together, right? But remember, what makes up a plane? Well, it's points and lines. So it's any points and lines on the same plane. Those are what we call coplanar. All right. So again, just to save time, I'll have a homework video that goes over more of this, but I'll just jump down to some more definitions. All right. So now we have our building blocks. We know what a point, we know what a line, and we know what a plane is, or are. All right. Now we can start actually using these to define other geometric figures. So three figures we're going to talk about, or 3 things we're going to talk about: segments, rays, and intersections. Again, things you've heard of. Okay, a segment, right? Think about a segment. A film has segments, right? A lot of things have segments. Segments mean part, right? It's part. So a segment is a part of a line with two endpoints, right? Remember, a line goes on forever and ever and ever. If I want to cut a piece of that line out, right, I just want a small piece of it, right? I want the middle piece, so I'm going to cut the ends off. Now I have a segment, so it has two endpoints, right? That is what a segment is. A ray, right? A ray is part of a line as well, but here's the difference between a segment and a line, right? A ray is a line with a starting point, so it does start, right? It has a beginning, however, they should say but, no ending, right? Right, so again, for a visual learner, right, these are both lines, right? A segment is, well, I'm going to cut off the ends because I want just the piece, right? A ray, on the other hand, says, well, I'm going to start and then I am going to never end. So I am going to start here and never end. Very, very different from each other. All right, so let's talk about naming these. All right, so naming a segment, very easy. You name it by its endpoints. All right, remember what I talked about on that last slide, right? When we start naming things, right, the first letter, right, the first letter is where you want to start. The second letter is where you want to end. So it just depends here. We have a whole bunch of segments, right? There are 3 segments just in this picture I've drawn on line AE. All right, so where do I want to start? That's my first point. Let's say I want to start at A, so I'm going to cut out A. And where do I want to end? Let's say I want to end at B, so that is segment AB. All right, maybe I want to start at B and end at E. That would be BE. All right, maybe I want to start at A and end at E. That's AE. Right, now to indicate we are talking about a segment, all right, you have to draw a segment above. Now people sometimes put endpoints on there. That's fine. I'm okay with just this, these lines with no endpoints, because that is a much different picture than the arrows. Okay. Now, the question that I brought up last time is, right, is AE different than EA? Do you cut out a different chunk? And look at that, right? Because again, remember, this says I'm starting at A, ending at E. This says I'm starting at E and ending at A. Well, if I start at A and end at E, that gives me this piece right here. Well, if I start at E and I end at A, does that give me a different piece? No, these are the exact same thing. Not always the case. All right, and we'll see that right here. So a ray, all right, so to name a ray, you need to use that starting point. You need to use that starting point. All right. The other, you have to use 2 points, so you're going to use the starting point, and you could pick any other point on the ray. All right. Just pick whatever point you want it to extend. So for example, all right, I could draw a line again here. Remember, a ray is just a piece of a line, all right, and a line has an infinite amount of points, so I'll just draw a few, A, B, C, D, E. All right, so remember, a ray, pick your starting point. So let's say I want to start at B. All right, so again, that's the first letter. You always write where you want to start. Now the question is, do I want to extend towards A or up? All right, so if I want to extend downwards, this would be called BA, because the starting point and A is downwards. That gives me this ray. If I want to extend up, well, again, I would start at B, and since I want to extend upwards, I have to pick a point up there. Now the question is, does it matter if I use C, D, and E? Well, is BC different than BD different than BE? I mean, aren't these all going on for infinity? So does it matter? Absolutely not. All right, and now just like the other ones, right, if you're talking about a ray, you draw a ray above it. Okay, last but not least, we're going to talk about intersection, right? You know what an intersection is, right? When two things collide, right? Two streets are intersections, right? The stop signs are at intersections, right? When two streets run into each other. So an intersection is a set of points that geometric figures have in common, what they share, where they collide, right? So intersections can be a point, can be a line, can be a plane, right? You can intersect at a whole bunch of things, all right? So you just need to name them accordingly. Okay, last thing we're going to talk about are what we call postulates or axioms. They mean the same thing. I personally use the word postulate all the time, but I want you to just be aware of both in case of like ACT or another class. A postulate is the same thing as an axiom. All right, two different ways to say the same exact word. And what it is, all right, it is just an accepted fact. The sky is blue. Now, obviously, there is proof and why because of that, because of the oceans and things like that. But it's just something we accept to be true. Right? The earth is round. Right? We accept it to be true. Now, yes, there are reasons behind those. Those are pretty bad examples. But you get the idea. Right? So a postulate is just an accepted statement or an accepted fact. All right, and just like our building, our undefined terms, point, line, and plane, we use facts as well to build geometry, right? We use logical reasoning to prove concepts. All right, now most postulates and axioms don't have names. They don't. There's a few special ones that do, and we'll get to those, but most of them don't. You can't Google postulate 1-1. You'll get a million different answers. All right, the way I am naming them is how our book is naming them, and our book just says we're in chapter 1, and this is the first postulate you are getting introduced to. That is why it's called 1.1 or 1-1. All right, it's our book's ordering. All right, this is not called postulate 1-1. There's no name for it. You need to know what it says, not its name. All right, so same thing for these other two, there's 3 total. All right, so here they are. They're pretty obvious. All right, but again, that's the point. Postulates are facts. Right, they should be obvious. Right, so if you draw 2 points, any 2 points. I don't care what 2 points you draw. So I got a pair of black ones there. I'll draw a pair of red ones here. I'll draw a pair of blue ones here. All right, through any 2 points. All right, through any 2 points, there is exactly one line. All right, there's only one line I can draw through these 2 blue points. Oops, I missed it. All right, there's only one line I can draw through these 2 black points. Only one. All right, no other one will go through these 2 exact points. All right, if I want the line to be steeper, I would have to move my point up or down, right? If I wanted it wider, I have to spread them apart more, right? Only one line can fit through 2 points. Okay, pretty obvious. Our next fact, all right, when 2 lines intersect, all right, think about 2 lines, all right, think about 2 streets. When 2 lines intersect, they intersect exactly at one spot. And what is that to us? Well, that spot is a point, right? So when 2 lines intersect, they intersect at a point. And again, that should make sense. All right, let's think about 2 planes. All right, this is the one people have the most trouble with. All right, think about a plane as like the ceiling and the wall, or the floor and the wall. All right, when 2 planes collide, all right, do you only get 1 point? I hope not. All right, look at your wall and the ceiling right now. All right, do they only touch at one corner? All right, is that the only spot that the wall and the ceiling are touching? I hope not. Otherwise, this building's gonna fall. Right? It's not gonna happen. All right, so two planes intersect to form, and you should be able to see it if you're looking at a wall. They form an entire line or a segment. All right, think about it. Let's draw um, a wall. All right, so let's draw a wall. Say this is the left wall of your room right now, and you want it to connect to the ground. Well, the ground is below it, right? And they share this whole side, right? And I'm going to just really bold it with two colors, right? They share that wall. They create that crease. They create that seam, right? It's an entire line that they share. All right, so those are our three basic postulates. We will add more. And again, here's some practice with that. Please do that on your own. And obviously, we do that in class. And there's, if you're having trouble with it, right, there's a homework video that goes through this a little bit more in detail. All right.